Welcome to Science for Sleep. We will explore the quiet mechanics of the mind, the processes that shape memory, perception, and consciousness when the world slows down. If you enjoy learning something real while you rest, take a moment to like this video, subscribe to the channel, and share your thoughts in the comments. Your support helps this space continue. Tonight's topic is something almost everyone has experienced. You wake up from a dream that felt vivid, emotional, even meaningful. And within minutes, sometimes seconds, it's gone. This is not a failure of memory. It is a feature of how the brain works. This video explores why the brain erases most dreams within 5 minutes, what science currently understands about the process, and the theories that attempt to explain it. There is no single answer, but there is a clear pattern. To understand why dreams disappear, we first need to understand what dreams are and what state the brain is in when they occur. Dreams primarily happen during REM sleep, rapid eye movement sleep. This stage occurs multiple times each night and becomes longer toward morning. During REM sleep, the brain is highly active. In many ways, it resembles the waking brain. Electrical activity increases. Visual regions activate strongly. Emotional centers become highly engaged. But there is one crucial difference. The systems responsible for forming stable memories are partially offline. Memory formation depends heavily on a structure called the hippocampus. The hippocampus acts as a temporary storage system, allowing experiences to be encoded before being transferred into long-term memory. During REM sleep, hippocampal activity is altered. Neurotransmitter levels shift dramatically. One of the most important changes involves norepinephrine. Norepinephrine is associated with attention, alertness, and memory encoding. During REM sleep, norepinephrine levels drop to some of the lowest levels seen in the entire 24-hour cycle. This chemical environment is not favorable for memory consolidation. In other words, dreams are generated in a brain state that is not designed to remember them. This alone explains part of the mystery. But it does not explain everything. Because some dreams are remembered. So why are a few preserved while most vanish? One theory focuses on emotional intensity. Dreams that contain strong emotion are more likely to be recalled. This is because emotional centers like the amygdala remain active during REM sleep. If a dream triggers enough emotional activation, it may briefly engage memory systems strongly enough to be retained. This does not guarantee long-term storage. It only increases the chance of recall upon waking. Another factor is awakening timing. If you wake directly from REM sleep, dream recall is much more likely. If you wake from non-REM sleep, dreams are often inaccessible. This suggests that dreams fade rapidly once REM sleep ends. The transition to wakefulness is disruptive. Neurochemistry changes quickly. Attention systems activate. External sensory input returns. If the dream is not immediately recalled, it is overwritten by waking consciousness. Some researchers describe this as interference. The brain prioritizes current reality over internally generated content. There is also a theory that dreams are never meant to be remembered. According to this view, dreams serve a functional purpose during sleep, not after it. Dreams may help process emotion. They may assist in memory integration. They may simulate scenarios. But remembering the dream is not necessary for those functions to occur. The work is done whether or not the dream is recalled. In this sense, forgetting dreams is not a flaw. It is expected. Another theory focuses on attention. Memory requires attention at the time of encoding. During dreams, attention is fragmented. The brain is not focused on creating a narrative for later recall. It is responding to internally generated signals. Without sustained attention, memories remain fragile. They dissolve quickly. There is also the issue of narrative instability. Dreams are not constructed like waking experiences. They lack continuity. Scenes change abruptly. Time behaves strangely. The brain struggles to store experiences that do not follow coherent structure. When waking consciousness returns, it tries to impose order. If the dream cannot be organized quickly, it disappears. Some scientists believe this is why dream journals work. Writing forces structure. By converting the dream into language immediately, you stabilize it. Without that step, the memory degrades. Another perspective comes from evolutionary theory. From an evolutionary standpoint, remembering dreams may offer little advantage. Dreams are internally generated simulations. They do not reflect real-world conditions accurately. Preserving them could interfere with accurate memory of waking experiences. For survival, the brain must prioritize reality. So the brain may actively suppress dream memory to avoid confusion. This suppression does not require conscious control. It happens automatically. Neuroimaging studies support this idea. During REM sleep, regions involved in critical evaluation and reality testing, particularly the prefrontal cortex, are less active. When waking resumes, these regions reassert control. Dream content is reclassified as irrelevant. It is discarded. There is also evidence that forgetting dreams protects emotional balance. Dreams often contain exaggerated or distorted emotional scenarios. Remembering them too vividly could carry emotional residue into waking life. By erasing most dreams, the brain limits emotional carryover. This may help stabilize mood. Another theory suggests dreams are a byproduct, not a function. According to this view, dreams emerge from neural activity related to memory consolidation and emotional processing. The narrative experience is incidental. The brain does not prioritize preserving incidental experiences. It prioritizes outcomes. Memory integration happens regardless of recall. From this perspective, dreaming is like seeing sparks during machinery operation. The sparks are visible but not the goal. Some neuroscientists also point to the role of acetylcholine. Acetylcholine levels are high during REM sleep. This supports cortical activation but disrupts hippocampal communication. The brain is active but disconnected from long-term memory storage. This creates a perfect condition for experience without retention. The moment you wake, acetylcholine drops. Other neurotransmitters rise. The brain shifts modes. The dream no longer has a place. This transition happens fast, often within seconds. This explains the familiar experience of knowing you dreamed, but being unable to recall details. The trace existed, then it faded. There is also the concept of state-dependent memory. Memories are more easily recalled when the brain is in the same state as when they were formed. Dreams are formed in a state unlike waking consciousness. Once the state changes, access is lost. This is similar to how certain memories are easier to recall when in the same emotional or physiological condition. Dream memory is locked behind a state that quickly disappears. Some individuals remember dreams more frequently than others. This appears to be related to differences in brain structure, attention to dreams, and awakening patterns. People who wake frequently during REM sleep tend to remember more dreams. Those who remain asleep through transitions remember fewer. This suggests that recall is linked to interruption. Dreams remembered are often dreams interrupted. This raises an interesting possibility. Dream recall may not reflect dream importance. It may reflect timing. Another theory proposes that forgetting dreams prevents overload. The brain already processes enormous amounts of information. Storing multiple dream narratives every night could clutter memory systems. Forgetting may preserve efficiency. It is also possible that dreams are partially remembered but not accessible consciously. Fragments may influence mood, creativity, or intuition without explicit recall. In this sense, dreams may leave traces even when forgotten. Some research supports this idea. Studies show that sleep influences emotional processing even when dream content is not remembered. This suggests that the effect of dreams persists beyond recall. Dream amnesia may be selective. The narrative is lost. The impact remains. Across cultures and history, humans have noticed dream forgetting. Ancient texts reference fleeting dreams. Modern neuroscience confirms the mechanism. Despite advances in imaging and sleep research, no single theory fully explains dream amnesia. It is likely the result of multiple interacting factors: neurochemistry, attention, memory systems, evolutionary priorities. Together they create a brain state optimized for experience, not retention. And that may be the key insight. Dreams are not messages meant to be remembered. They are processes meant to occur. They serve the brain, not the ego. As sleep continues, the brain cycles through this state again and again. Each time experiences arise. Each time most are released, not because they are meaningless, but because their role is temporary. As this video continues, we'll explore how dream forgetting relates to creativity, emotional health, lucid dreaming, and what happens when this process changes. For now, it's enough to understand this. The brain forgets dreams quickly because it is designed to, and that forgetting is part of how sleep works. As we move deeper into what science understands about dream forgetting, it becomes important to talk about what happens when this process does not work in the usual way. Not everyone forgets dreams at the same rate. Some people remember dreams frequently and vividly. Others rarely recall dreaming at all. This difference has been studied, and it reveals more about how the brain handles dream memory. Research shows that people who recall dreams often tend to wake more frequently during the night, even briefly. These awakenings are often so short that the person does not consciously notice them. But during these moments, the brain shifts closer to a waking state. This shift allows dream content to be transferred, temporarily, into short-term memory. Without that interruption, the dream remains contained within sleep-related brain networks and fades when the state changes. In other words, remembering dreams often means sleep is slightly less continuous. This does not necessarily mean worse sleep. It means different sleep architecture. Dream recall is linked to how easily the brain transitions between states. Another factor involves personality traits. Studies have found correlations between dream recall and traits like openness to experience, introspection, and imagination. This does not mean dream recall is psychological rather than biological. It means attention plays a role. People who naturally reflect inward may be more likely to notice dream fragments before they disappear. Attention strengthens fragile memory traces. Without attention, those traces dissolve. There is also evidence that the brain regions involved in self-reflection remain slightly more active in frequent dream recallers. This suggests that their brains maintain a thin bridge between dreaming and waking awareness. That bridge allows information to pass briefly. Lucid dreaming offers another perspective. During lucid dreams, the dreamer becomes aware that they are dreaming. Neuroimaging studies show that during lucid dreaming, parts of the prefrontal cortex become more active than during normal REM sleep. This reactivation supports metacognition, the ability to think about thinking. It also supports memory formation. This is why lucid dreams are often remembered more clearly. The brain is closer to a waking configuration. However, this comes at a cost. Lucid dreaming can reduce the depth of REM sleep and may interfere with some of its restorative functions if it occurs frequently. From a scientific standpoint, dream forgetting may protect sleep quality. Keeping consciousness partially engaged during dreaming may reduce the efficiency of sleep-related processing. Another situation where dream forgetting changes is trauma. In individuals with post-traumatic stress disorder, dreams are often remembered too well. Nightmares recur. Details persist. Emotional intensity carries into waking life. This suggests that the brain's usual mechanisms for dampening dream memory are altered. Stress-related neurotransmitters remain elevated during sleep. The amygdala remains highly active. Memory systems become more engaged. In this case, dream forgetting fails to protect emotional balance. This reinforces the idea that forgetting dreams is adaptive. It prevents emotional overload. It allows the brain to process experiences without repeatedly reliving them consciously. Another question scientists explore is whether forgetting dreams affects creativity. Many people report creative insights emerging from dreams, even when the dreams themselves are not remembered clearly. This suggests that dream processing can influence waking thought indirectly. The brain may integrate ideas during sleep and present the result, rather than the dream itself. This supports the idea that recall is not the goal. Outcome is. The dream is the process. Insight is the result. Age also influences dream recall. Children often remember dreams more frequently. Older adults tend to recall fewer dreams. This may be related to changes in sleep architecture. As people age, REM sleep becomes shorter and more fragmented. Memory systems also change. The combination reduces dream recall. This does not mean older adults dream less. It means fewer dreams are transferred into waking memory. Another area of interest involves technology. Sleep tracking devices can detect REM sleep but cannot access dream content. Some studies suggest that awareness of sleep cycles increases interest in dream recall. However, without immediate attention, forgetting still occurs. The biological mechanisms remain dominant. Some researchers have asked whether it is possible to train the brain to remember dreams consistently. Dream journaling can increase recall. Setting an intention to remember dreams can also help. These techniques work by increasing attention at the moment of waking. They do not change how dreams are formed. They change what happens immediately after. Even with training, most dreams are still forgotten. This suggests a limit imposed by brain chemistry. Another theory worth considering is that dream forgetting helps preserve identity. Dreams often involve shifting perspectives, identities, and impossible scenarios. If remembered vividly, these experiences could blur the boundaries of self. Forgetting maintains coherence. The waking self remains stable. This may be especially important for social functioning. Across cultures, dreams have been interpreted as messages, symbols, or insights. Science does not deny that dreams can feel meaningful, but neuroscience suggests that meaning is assigned after waking. The dream itself is raw material. The brain extracts what it needs and discards the rest. This aligns with what we know about memory more broadly. Most experiences are forgotten. Only a small fraction are retained. Dreams follow the same rule but more extremely. They are formed in a state where forgetting is favored. As research continues, scientists are exploring how dream memory interacts with mental health, learning, and emotional resilience. Early findings suggest that healthy dream forgetting supports balance. Too little recall may limit emotional insight. Too much recall may increase distress. The brain appears to aim for a middle ground. It allows dreams to occur. It allows some to be remembered. It releases most. This balance has been shaped over time. It is not accidental. And it explains why that vivid dream from moments ago can vanish so quickly. Not because it lacked meaning, but because its purpose was already fulfilled. As this exploration continues, the central idea becomes clearer. Dreams are not meant to be stored like memories of waking life. They are meant to pass through the brain, leave subtle traces, and move on. And forgetting them is part of how the brain protects clarity, stability, and function. As we continue, it's useful to look more closely at what happens in the moments after a dream ends, because this window explains why forgetting is so fast and so reliable. When REM sleep ends, the brain does not ease gently into wakefulness. It switches priorities. Neural resources that were focused inward are rapidly redirected outward. Sensory processing resumes. Posture, balance, and orientation systems activate. Attention locks onto the environment. This shift is competitive. The brain has limited capacity. When waking systems activate, internally generated material loses priority. Dream memory traces are fragile. They have not yet been stabilized. They exist as temporary patterns of activation rather than encoded records. Once attention shifts, those patterns decay. This is why even the effort to remember a dream can feel like chasing something that is dissolving as you reach for it. The more you think about waking tasks, the faster the dream disappears. This is not unique to dreaming. In waking life, many fleeting thoughts and sensations are also forgotten. Dreams simply occupy the most fragile end of that spectrum. Another important element involves language. Dreams are experienced primarily as images, emotions, and sensations. Language centers of the brain are less active during REM sleep. When you wake, you attempt to translate a nonverbal experience into words. This translation is difficult. If the brain cannot quickly attach language to the experience, the memory fades. This is why dream fragments often disappear as soon as you try to describe them. They were never stored in linguistic form. The act of speaking or writing forces structure. Without that structure, the dream remains unstable. This leads to another key idea. Dream forgetting may not be a single process. It may be several processes occurring simultaneously. Chemical conditions prevent strong encoding. Attention shifts disrupt fragile traces. Language translation fails. Evolutionary priorities suppress retention. Together, they create near-total forgetting. This redundancy suggests that dream amnesia is strongly favored by the brain. If one mechanism fails, others still operate. From a biological perspective, this level of redundancy usually protects something important. In this case, it protects waking cognition. Now consider what happens when people deliberately interfere with this process. Dream journals, repeated awakenings, and lucid dreaming practices increase recall. But they also change sleep architecture. Frequent awakenings fragment REM sleep. Lucidity reactivates waking networks. This does not mean these practices are harmful, but it shows that remembering dreams comes at a cost. The brain must partially sacrifice efficiency to preserve recall. This trade-off supports the idea that forgetting dreams is the default for a reason. Another area of research involves mental imagery during wakefulness. Some people report vivid imagery when relaxed or daydreaming. Interestingly, these individuals often recall dreams more frequently. This suggests a shared mechanism. The brain regions responsible for imagery and internal simulation may remain more active across states. This makes dream content easier to access after waking. But again, this is not universal. The average brain does not maintain this bridge. It closes it quickly. There is also evidence that stress alters dream forgetting. During periods of high stress, people often remember dreams more vividly. Stress hormones influence memory systems. They increase the likelihood that emotional content is retained. This can override the usual forgetting mechanisms. However, this also increases emotional carryover. The brain normally avoids this. This reinforces the idea that dream forgetting protects emotional regulation. Another theory suggests that dream forgetting supports learning efficiency. If dream narratives were retained, they could interfere with distinguishing imagined experiences from real ones. The brain already struggles with false memories. Dream recall could increase this risk. By discarding most dreams, the brain reduces confusion. It preserves a clear boundary between simulation and reality. This boundary is essential. Even young children, who often confuse imagination and reality, gradually develop this separation. Dream forgetting may support that developmental process. From a computational perspective, dreams may function as internal testing. The brain explores combinations of memories and emotions. Once tested, the results are integrated. The test itself does not need to be stored. This is similar to how a computer runs simulations. The output matters. The simulation data does not. This analogy appears frequently in neuroscience discussions. Dreams are a sandbox. The sandbox is cleared after use. Some researchers have proposed that dreams help reduce emotional charge attached to memories. By reactivating emotional content without reinforcement, the brain weakens the emotional response. This process does not require recall. In fact, recall might interfere with it. Forgetting ensures the emotional adjustment occurs without re-triggering stress. This idea is supported by findings in REM sleep and emotional memory processing. Another question often asked is whether animals forget dreams. While we cannot ask animals about dream content, neural replay has been observed in many species. Animals show patterns during sleep that resemble waking experiences. These patterns fade after waking. This suggests that forgetting internally generated content is not uniquely human. It is a general feature of sleeping brains. Across species, the brain prioritizes learning outcomes, not dream narratives. Another factor to consider is cultural interpretation. In cultures where dreams are emphasized, people often report higher dream recall. This suggests expectation plays a role. When the mind expects dreams to matter, attention increases upon waking. This attention stabilizes memory traces. But even in these cultures, most dreams are still forgotten. Expectation modifies recall. It does not override biology. There is also evidence that the brain actively suppresses dream memory. Studies show reduced activity in memory retrieval networks immediately after REM sleep. This suggests forgetting may be intentional at a neural level. The brain does not simply fail to encode dreams. It may actively inhibit recall. Why would it do this? Because waking cognition requires clarity. Dreams are unconstrained. They violate logic, physics, and identity. Carrying too much of that content into wakefulness could disrupt functioning. The brain chooses stability. As sleep continues across the night, dream production repeats. Each cycle generates experiences. Each cycle releases most of them. This repetition does not indicate waste. It indicates processing. The same memory may be reworked across multiple dreams without being remembered. The effect accumulates. The narrative does not. As we move deeper into this discussion, the pattern becomes clear. Dream forgetting is not accidental. It is layered, redundant, and adaptive. It reflects the brain's priorities. Clarity over content. Function over story. Outcome over experience. The fact that dreams feel meaningful does not mean they need to be remembered. Meaning can exist without memory. And the brain appears to understand this. As we continue, the discussion naturally leads to a deeper question. If dreams are forgotten so reliably, what does that say about consciousness itself? During waking life, consciousness feels continuous. There is a sense of a stable self moving through time. During dreams, that stability disappears. Identity shifts. Perspective changes. Contradictions are accepted without resistance. This tells us something important. Consciousness is not a single state. It is a configuration. When you dream, the brain constructs experience without the systems that normally anchor memory, logic, and identity. This configuration is temporary. When you wake, the configuration dissolves. The memory dissolves with it. One theory suggests that consciousness during dreams is deliberately decoupled from autobiographical memory. Autobiographical memory allows you to know who you are, where you are, and what has happened before. During REM sleep, this system is reduced. This allows the brain to explore scenarios without tying them to the self. If dream experiences were strongly linked to autobiographical memory, they could become confusing or disruptive. By weakening this link, the brain allows exploration without ownership. When you wake, the brain restores autobiographical continuity. Anything that does not fit is discarded. This may explain why dreams often feel like they happened to someone, even though you were present. The self in dreams is not the waking self. Because the waking self is not fully present, the memory does not attach. Another important idea involves predictive processing. Modern neuroscience increasingly views the brain as a prediction machine. It constantly generates models of reality and updates them based on input. During sleep, external input is minimized. The brain turns inward and generates predictions without correction. Dreams may be extreme expressions of predictive activity. They test possibilities. They explore emotional outcomes. They combine memories in unusual ways. Once waking input returns, these predictions are no longer useful. They are replaced by real data. The predictions are discarded. From this perspective, dreams are provisional. They are not meant to persist. Their role is internal calibration. This also helps explain why dreams often feel nonsensical. They are not narratives meant for storage. they are models meant for adjustment. Another line of research focuses on synaptic homeostasis. Throughout the day, synapses strengthen as you learn and experience the world. This strengthening has a cost. If unchecked, it leads to inefficiency and noise. Sleep is thought to help rebalance synaptic strength. Some connections are weakened, others are preserved. Dreams may reflect this reorganization. They may be the subjective experience of synaptic adjustment. If so, remembering the dream would be irrelevant. The adjustment happens at the synaptic level. The dream is a side effect. Once the adjustment is complete, the side effect disappears. This aligns with findings that sleep improves learning even when dream recall is absent. The benefit does not depend on memory of the dream. Another area worth exploring is imagination. Dreaming uses many of the same networks involved in imagination and mental simulation. When you imagine something while awake, you know it is imagined. This awareness depends on prefrontal control. During dreams, that control is reduced. The imagined becomes experienced. But because prefrontal oversight is reduced, the experience is not labeled for storage. It remains transient. This explains why dream experiences feel real in the moment but unreal upon waking. The brain retroactively classifies them as non-events. This classification triggers forgetting. Some researchers believe this is an active process. Once the brain determines that an experience did not occur in the external world, it deprioritizes it. Memory systems filter it out. This filtering is essential. Without it, hallucinations, imaginings, and dreams could contaminate memory. Dream forgetting preserves reliability. Another interesting question is whether dream forgetting influences belief. People often feel that dreams carry messages or meaning. Science does not deny the emotional impact of dreams, but it suggests that interpretation happens after waking. The dream itself is raw. Meaning is assigned later. Because most dreams are forgotten, only a small subset become interpreted. These are often emotionally intense or unusual. This selection bias may explain why remembered dreams feel special. They are not representative. They are exceptions. Most dreams are ordinary, fragmented, and quickly lost. We simply do not remember them. This also means that the dream content people analyze is not a full sample. It is a filtered subset. Science therefore focuses more on mechanisms than narratives. The mechanism is clear. Dream forgetting is systematic. It occurs across cultures, ages, and species. It is influenced by chemistry, attention, and brain state, and it serves multiple functions. As the night progresses, REM periods lengthen. Dreaming increases. Yet recall does not increase proportionally. This suggests that forgetting becomes even more efficient. The brain is not overwhelmed. It maintains control. Toward morning, when waking approaches, recall becomes more likely. This is why many remembered dreams occur just before waking. The boundary between states is thinner. But even then, most dreams vanish. Only fragments cross the threshold. As sleep ends, the brain completes its work. Synapses are adjusted. Memories are integrated. Emotions are regulated. The dreams that accompanied this work are no longer needed. They are released. As we approach the final portion of this script, the broader picture comes into focus. Dream forgetting is not a mystery waiting to be solved. It is a pattern waiting to be understood. It reflects how the brain balances exploration and stability. It allows freedom during sleep and clarity during wakefulness. It protects the self. It protects reality. And it allows the mind to reset without carrying excess noise forward. Each night, the brain enters a state where normal rules loosen. Logic softens. Time bends. Identity becomes fluid. This is not chaos. It is controlled flexibility. Dreaming allows the brain to explore combinations of memory, emotion, and prediction without consequence. It can simulate fear without danger. It can replay experience without commitment. It can rearrange information freely. But freedom without limits would be costly. So the brain builds a boundary. That boundary is forgetting. By allowing dreams to exist fully during sleep, and then releasing them, the brain gains the benefits without the burden. This balance is one of the most elegant aspects of sleep biology. Consider how different waking life would be if dreams were remembered in full detail every night. Memories of flying, falling, losing identity, or reliving emotionally intense scenarios would stack on top of real experiences. The distinction between lived and imagined events would blur. The brain avoids this by design. It filters. It selects. It lets most internal experiences pass through without imprinting them permanently. This is not unique to dreaming. Much of waking thought is also forgotten. Random ideas, passing emotions, momentary images. The brain constantly generates more content than it retains. Dreams simply represent the most extreme case. They are rich in experience but poor in storage. This is because storage is expensive. Memory formation requires energy, stability, and chemical support. The brain invests those resources selectively. Dreams rarely meet the criteria. Another insight from neuroscience is that forgetting itself is an active process. For many years, forgetting was thought to be passive, a failure to retain. Now we know that the brain actively removes information. It weakens connections. It suppresses retrieval pathways. It prioritizes relevance. Dream forgetting appears to involve this active pruning. When waking resumes, the brain evaluates what just occurred. Was it external? Was it useful? Does it align with current goals? If the answer is no, the memory is released. This happens quickly, often before conscious reflection can begin. This speed is why dream recall feels slippery. By the time you try to grasp it, the brain has already moved on. This process also explains why fragments sometimes remain. An image, feeling, a single moment. These fragments may linger because they intersected with emotion, identity, or recent memory. They had enough relevance to resist immediate removal. But even these usually fade. The system is biased toward letting go. From a broader perspective, dream forgetting reflects how the brain manages information overload. Every day brings massive sensory input. Every night brings internal processing. If everything were retained, clarity would suffer. Forgetting is not a failure of memory. It is a requirement for function. Dreams highlight this truth because they are forgotten so consistently. They show us that experience and memory are not the same thing. You can experience something fully and still let it go. This has implications beyond sleep. It suggests that not everything meaningful must be remembered to have value. Dreams may influence creativity, emotional balance, and problem-solving without leaving a narrative trace. The effect remains even when the story disappears. This is why people often wake with a changed mood or a new perspective without knowing why. The brain has already done the work. The dream does not need to be recalled. As neuroscience continues to study sleep, the focus is shifting away from dream content and toward dream function. What matters is not what was dreamed, but what changed because of it. Memory integration, emotional recalibration, synaptic adjustment. These processes operate quietly. They do not announce themselves. They do not require awareness. Dream forgetting ensures they remain efficient. It keeps sleep from becoming another waking task. As this video comes to a close, it's worth holding on to one final idea. Dreams are not lost because they failed to matter. They are forgotten because their purpose was temporary. They were part of a process, not a product. Each night, the brain allows experiences to arise, do their work, and dissolve. This cycle repeats endlessly. Most of it happens beyond awareness. And that is exactly how it is meant to be. If you've stayed with this exploration, thank you. If you found value here, consider leaving a like, sharing your thoughts in the comments, and subscribing to Science for Sleep. This channel exists to explore the mind with curiosity, clarity, and respect for what science shows us. And now, as this discussion ends, the topic itself offers a quiet parallel. Just like a dream, these ideas can be held lightly. Whatever stays, stays. Whatever fades, fades. The brain knows how to let go. And that, too, is part of its intelligence.